All right, number 39, solving rational equations. Again, I'm giving you the titles of all these things in case you need to go back and look at it in the actual videos instead of just looking at the shortened version or me running through it so quickly. If you need a more in-depth conversation of how to do these problems, go back and look at the video that's dealing with that specific problem. So solving rational equations, you have to find a common denominator. Easiest way to do that is take the highest of the exponents, so that's going to be m squared, and then take the least common multiple of the numbers out in front, which in this case is 1, 3, and 3. The least common multiple of 1, 3, and 3 is just 3. So my common denominator is 3m squared. Now, once we have that, we're going to go ahead and write the top numbers down. Now we have to figure out, hey, what was missing to get to this term? Well, m squared times what gives me 3m squared? Well, that's going to be a 3. So I need to multiply the top by a 3. I have a 3m. I need 3m squared. What was missing? An m, so that goes on top. 3m squared, 3m squared. Nothing was missing. Okay? Now, once we have this, we can cancel out the denominator and just work with the top. 3 times 1 is 3, equals 1 times m is m, minus 5. Solve the equation. Sorry. That's your solution. Okay? The only thing that you have to check is, hey, if I plug this back into the denominator, will it give me 0? The answer is no. If it gave me 0, it would be no solution. But in this case, the problem works, so m equals 8. 40 is a little bit more complex. You have to factor each term before you can do anything else. And this is somewhat of a pain, but you need to factor the denominators. So take out a 2 out of this one, so that leaves me with a v plus 6. Right here, I can take out a 2v, and that leaves me with v plus 6. And then right here, it's just a v. Okay? So now, I need to find a common denominator of all of this stuff. Well, look at your numbers first. 2, 2, and 1. Least common multiple of 2, 2, and 1 is just 2. So that gets a vote to go on bottom. V plus 6, we're going to need a v plus 6. Everything has to be accounted for. And then there's one more thing that's not accounted for. It's the v that's chilling right there. Okay, so we're going to put a v in there as well. So now that's my denominator. Okay. Now we have to work with the top and figure out what was missing. So this is what we need. This is what we had. The v was missing, so remember, go ahead and write all your numbers down. The v was missing, so I put a v in. From here to here, what was missing? Nothing. Nothing was missing, so we can leave that one alone. From here to here, what was missing? Well, the 2 and the v plus 6 was missing here. Okay, so that 3 is going to have to be multiplied by all of that. So, again, cancel out the denominator. V equals 1 plus 3 times 2 is 6. Now I need to take the 6 and multiply it to both of those terms. 6 times v, 6v. 6 times 6, 36. Solve that equation. Subtract the 6v, negative 5v equals 37. Divide by negative 5. V equals negative 37 over 5. Okay? Again, make sure that you can plug it back in and it works. The only thing that wouldn't work would be a 0 and a negative 6. That's not either one of those. So that is our solution. Number 41 deals with solving square root equations with a square root on both sides. So if you need more help with this, look it up on the video. But what you need to do is square both sides. Okay, that cancels out the square root. So now we have 2v minus 11 equals 19 minus v. That's a very easy equation to solve. Get all your v's on one side, all the numbers on the other. Add v. 3v minus 11 equals 19. Add 11. 3v equals 30. Divide by 3. V equals 10. Okay, plug it back in to make sure it works. 19 minus 10 is a 9 there. 20 minus 11 is a 9 there. Everything's good, so now we can move on. 42 asks you to sketch the graph of the function. If you have a graphing calculator, then this makes this process a lot easier. If you don't have a graphing calculator, you need to know a little bit about what they look like. I'm going to give you a starting point and then kind of go from there. Remember, finding the starting point, opposite of the inside, keep the outside. So our starting point is at -1, 1. Okay, so if we're looking at the graph of this, -1, 1 is right here. Cubic functions. Cubic functions look like S's or sideways S's. So our graph should look something like that. But remember, it should be bending around this point. So if you know what the starting point is, then you should be able to figure out how to graph that thing. The nice thing about cubics, all cubic functions, the domain is all real numbers. The range, all real numbers. I can plug in anything I want to. It's going to give me an answer out. Okay? 43, a little bit different. But we started off the same way. This time, it is not cubic. It's just a square root function. So our starting point, opposite inside, keep the outside. -6, 2. Look at your graph, -6, +2. A square root function does not go in both directions. It actually just goes in one direction, like that. Now, your domain, everything to the right of -6. So you might see it like that. X is greater than -6. Your range, everything above 2. So y has to be greater than 2. Okay? Remember, with cubics, domain and range are all real numbers. With square root equations, then they're going to be opposite inside. Keep the outside and look at your graph from there. So 44 works along the same exact lines. I told you in my class to make this make a little bit more sense, you can actually take this -2 and move it to the other side. It is not being multiplied by the square root. If it was being multiplied, you cannot do that. But since it's not being multiplied, you can do that. So square root of x plus 5 and then -2. Same exact equation. Opposite of the inside, keep the outside. Opposite of the inside, keep the outside. So starting point's at -5, -2. So that means my domain is anything greater than -5. My range is anything greater than -2. Okay? The only time that would change is if there's a negative out here or a negative right there. There's not, so no reason to worry about what's going on there. 45, ask you to graph the function that function. Okay? This is getting into the graphs of rational equations. If you need to brush up on this, you need to go look at it on the videos. I'm not going to do it justice right here. I'm going to give you the shortcuts. If you need to really look at this, go on the video. Okay? So, first of all, graphing calculator. Type the thing in, play the matching game. Okay? But what we're looking for here is VA, HA, SA, wholes. And that should give you a good idea of what's going on. Vertical asymptote. Denominator equals 0. X minus 1 equals 0. X equals 1. We know there should be a vertical asymptote at 1. Horizontal asymptotes. Degree of top less than bottom. So that means y equals 0. Okay? So right now, if we're looking at our graph, we know that this thing should be doing something like this. And then it's going to be in one of these quadrants. There's no slant because there's a horizontal. There's no hole because nothing cancels. So if we're looking at the graph, I haven't even sketched it yet. I haven't looked at it, but I think it ends up doing something along those lines. Okay? Or actually, it might be inverted. So let's see. Yep. This thing's actually going to end up looking like that. Okay? But again, type it into a graphing calculator. It'll give you your stuff. If not, look for your asymptotes. That'll be the end of this video. I will pick up with number 46 in the next one.